Okay, let's continue. This is our first example of stretching. So y, we're asked to graph y equals 2x squared. So we say, let's describe the transformation. So we say the parent graph. What is the parent graph? Y equals x squared will, so let's list down the transformation here. There's only one. Vertically stretch by a factor. Don't say by 2. Always write by a factor of 2. So we are going to stretch and our factor is 2 before we tried 3. Okay, so here let's draw the parent graph. I hope you know how to draw the parent graph very quickly. Okay, x, y, arrowhead. Without the arrowhead, you're not going to get perfect score. Okay, 0, 1, 1. So what are the points of the parabola? 0, 0, 1, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, and on the other side too. Okay, you can do your parent graph in less than, you should be able to do it in less than 10 seconds. Okay, so here, this is your parent graph, and this is what we're going to stretch by a factor of 2. Okay, stretch by a factor of 2. So we're going to stretch not the parabola but the points. I taught you how to stretch the points. Okay, so when the point is on the x-axis, okay, you cannot stretch it because it is anchored on the x-axis, or the distance from the x-axis is 0. So that will still be the stretch point of that point. Here, the distance between the x, so we're going to stretch this by a factor of 2. So 1 times 2 is 2. It will be here. Okay, now you're not going to put all of this 1 above, not like that. That's translation. Okay, every point will move a different number of units. It's not, oh, 1 above, 1 up, 1 up, 1 up. That's translation. That is not stretch. Okay, so this point is 1, 2, 3, 4 away from the x-axis. 4 times 2, because our factor is 2. So now 8. So we will count another 1, 2, 3, 4. You see? This is 4. This is 1. So this is not translation. It's not the same for every point. Now this point, how are we going to stretch this by a factor of 2? So we will see how far it is from the y-axis. We know that that is 9. So we're going to count another 9 here. Okay, I hope we can make it. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, it's somewhere there. We cannot make it. We should have, okay, it's somewhere there. Alright, so then you can just use symmetry on the other side. So you just try to follow it. So this will be here. Symmetry, 1, 2, 1, 2. And then we say somewhere there. Okay, so this is our stretch graph. Then you just join them. You see it will become stretch up. Okay, it become narrower, or stretch, right? Okay, so that is stretched by a factor of 2. What about factor of 3? Will it be narrower than this one? Try to answer that. Okay, let's try here. Let's combine it with, I hope you understand how to stretch by a factor of 2. Okay, let's just do our sum of the important lines and points. Okay, so here, let's say our vertex, let's just draw our vertex here, is still at 0, 0. Our line of symmetry is the line x equals 0. Our x-intercept is on 0, 0. So is our y-intercept. And getting the points of the red graph, okay, not the parent graph. And our domain is still all real numbers. Domain is always all real numbers for any parabola. It's always all real numbers. And our range will be from 0 to positive infinity bracket. Bracket 0 to positive infinity. Okay, on the next one here, we're going to combine two. Okay, let's see how we're going to graph this function here. Okay, so when you do the x and y so what will I describe first? When you do the x and y table, okay, if you say, let's say you give value 1, what do you do first? You substitute it here, right? And then you square it. Then you multiply it by 3. So that is also the order of how you're going to describe your transformations. So you're going to do this first. So you will say the parent graph y equals x squared will translate 5 units to the right, translate 5 units to the right, and but what will that 3 do? Okay, that 3 will vertically stretch it by a factor of 3. Vertically stretch by a factor of 3. Remember, it's bigger than 1, so it's a stretch. Okay, let's do this. So we do the parent graph here. Okay, so this is our xy. So 1 1, so 0 0 1 1 1 2 3 4 5 6 7 8 9. We always do our parent graph first until you get used to it. You're going to use this also in your algebra 1, so be sure that you know how to draw your parent graph for quadratic function. Okay, now we're going to translate these 5 units to the right. So every point will move 5 units to the right. But as a technique, what we said, we only move the vertex 1 2 3 4 5, and then we just draw our parent graph. If you like to count one by one, that's okay too. It's up to you. But for me, I just draw it again here. I just count 1 1 2 4 3 9. Or you can move each one of that. It's up to you. Whatever is easier for you. 1 2 3 1 2 3. Okay, so this is now my parent graph. Then we use dashes here. It should be symmetrical. It should look like your parent graph. You just moved it, or you just translated it 5 units to the right. Okay, so these are now our points. These are the points that we're going to stretch one by one. We're going to stretch this. Actually, we're going to stretch only these 3 points, and then we will use symmetry, right? Okay, so I taught you how to stretch by a factor of 3. Don't mind everything. Don't look at the others. Just look at the point and its distance from the x-axis. That is 1. So the factor is 3. So times 3, it will be here. This point will be here. This point is 0. Times 3 is still 0. It's not going to move. This point is 4 units away from the x-axis, times 3. So that will be 12. 4, 8, 12. Okay, so you could see there are 4 times as much as it is stretched. Now this is 9. Times 3 is 27. So I have to move 27 here. That will be too much up there. We're not going to graph it anymore. Okay, we're just going to use an arrow there. So we're just going to use symmetry. The other point on the other side is here. Okay, because this is our line of symmetry, the middle line. Okay, so now that is the line 1 2 3 4 5. X equals 5. Okay, that